In this video, I want to talk about Azure VNet transitive routing. So the fundamental around transitive routing is mostly around when you build a hub and spoke network. Now, if you see on the screen, I am just following the same example which I followed for the firewall use case. Now, in this use case, what we will be doing is we will be talking about not only using the firewall for filtering or managing your traffic, but also using the firewall as a router so that it can basically route the traffic between your spokes. So someone who is watching this video hadn't been through the firewall video. So just to give you a brief overview. So we have a spoke 1, which is one of our spoke network. And then we have a spoke 2, which is our second spoke. And then we have a hub network. So the idea behind this entire model is all around the hub and spoke, which is, I think, so one of the conventional way how networks are designed. Now, there are like a lot of different benefits why exactly you would like to build a hub and spoke model, which obviously you can have a read. And on a very high level, it basically helps you in centralizing your entire traffic management. And obviously, you can also deploy your core services, things like Active Directory, things like your domain controllers and stuff like that in your hub. And obviously the firewall and all the security aspects within the hub so that everything can be central managed, and then all the spokes are basically connected to the hub. Now, in this particular use case, what we want to discuss is mostly around what if I have a spoke network 1 over here and spoke 2 over here. Now, obviously, they can talk to the hub network because, as you can see, we have a peering. So this is a VNet peering, which we normally enable between the spoke and the hub network. But what if the requirement is that, and I'll quickly draw over here. So what if our requirement is mostly around something on VM1 wants to talk to the VM2? So if we need a communication like this, now what can be the different use case why exactly you would need this communication? So let's assume we have an application which is app1, which is running on VM1, and let's assume our database, which is DB, which basically serves our application 1, so DB1, it's residing on VM2. Now, in order for the application to work, this communication needs to work. So application 1 should be able to talk to database 1 so that it can get the data. Now, in order to achieve this, there are different ways how you can do that. And one of the common example and one of the way how you can do it is you can basically build a peering. So similar to what we build a peer between our hub and spoke. So we can build a peer over here. Now, the idea why you should not, or you are not ideally not allowed to do it if you're building a hub and spoke network is if you're doing this, then you are basically violating the entire traffic management, which ideally should go through your hub. So all that is basically goes null and void because now your VM1 and your spoke 1 is talking to your spoke 2 directly without the hub even knowing about it. So that's why this is something which is not a good practice or not something which is recommended, which you should not do. So ideally, what should be the way? So let me just clean this up. Okay, let me take a moment. Yeah, so let me clean that up. So now we have, okay, that's the max what I can control Z. So let me clean this. That's all gone. Yeah. All right. So ideally, so how exactly should it work? And the way how it should work is what I have shown over here. So we have a spoke 1, which is connected using the peering option to our hub, and then spoke 2 is connected to the peering option with hub. Now, what will happen is if V1 wants to talk to VM2 because of the apps and database model, then what VM1 will do is it will basically talk to the hub network. In the hub, we will have our firewall, and it can be any NVA because most of the NVA by default supports a routing capability. So in this particular demonstration, we will be using Azure Firewall. In the Azure Firewall, what we will have is will have the routing logic of, okay, if the traffic is coming from our spoke 1, and it is expected to go to spoke 2, then the spoke 2 is basically residing on this particular range. So what we'll provide is we'll provide the address space or address prefix where the traffic should go, and that all configuration is done over here. And then on the other side, which is the spoke, so once the traffic is received, it will be processed over there and it will reply back. So again, there should be a reverse traffic or reverse configuration, that if the traffic is coming from spoke 2 and it is asking to go to spoke 1, that configuration should be listed over here as well. So once we have done the two-way configuration, then we should be able to access any resource on VM1 from VM2 or any resource on VM2 from VM1. One of the additional thing which will be required over here is a route table. The reason for a route table over here is because at this particular subnet level, and just to clarify, the route table are basically associated to a subnet. So you can have one route table which can be associated to multiple subnets and otherwise. Now in this particular use case, what we will have is, in order for VM1 to talk to VM2, the subnet 1 should be or maybe the VNet 1 should be able to talk to the VNet 2. So in that case, what we do is we basically configure this route table with and we will be basically naming it as 2 spoke 2. And what that means is any traffic which is getting generated at for this particular IP range should first go to the firewall. Now what that means is, if you see 172.19.0.0.16, that's our VNet to IP range. Now that particular request, once it is generated from VM1, it first go to 172.17.1.4, which is basically our firewall IP. Now once it is over here, then we have that bridging logic of any traffic which is required to go to 172.19.0.0.16 should, and coming from 172.18.0.0.16 should basically connect using this particular configuration. So what exactly in a nutshell we are doing over here is we are basically building that bridge. So what happens is a user comes over here and he wants to access the database. So what happens is, this particular request, first it says that, okay, now because you want to access the database, I cannot find database anywhere locally. So it's basically sitting on 172.19.0.16. So first the particular database request goes to our database, our firewall network, which is the hub network. Now once it is received over there, it basically has that bridge. So the bridge is basically defined in the firewall, and that bridge helps in connecting this part, which basically helps the request to be received by the VM2, which is on spoke 2. Now so yeah, this is more about what we will be covering today, and I'll quickly show you how you can implement that. So going back to the Azure portal, as I explained in the previous session on the firewall, that we have this particular environment, which is our first running resource group, and inside that we have a couple of resources. The one which we will be focusing on today is the VM1 and VM2, because if you look into the diagram, so that's the VM1 which is in spoke 1 and VM2 is in spoke 2. And the other thing which we will be focusing on is this route table. So we have a spoke 2 route table, we have a spoke 1 route table, and finally we have the firewall which is sitting in the hub network. So the focus area would be only these 5 things: the VMs, the route tables, and the firewall. So let's first go to the spoke network. So this is our spoke 1, and spoke 1 is basically what is connected to the is what we are referring to, the VNet 1. So now if you see over here, what I've done is I've just quickly configured a specific route inside the route configuration, and if I'll open that, what it says is that if any request is asked to go to 172.19.0.0.16, which is the address space, then the first next hop type should be a virtual appliance, in this case, which is Azure Firewall, and that's the IP address 172.17.1.4. So if I go back over here, that's what I was referring to. So anything which is required to go to 172.19.0.0.16 first should go to 172.17.1.1.4, and from there it will be navigated. So the routing of this particular traffic will be all managed by the firewall. So that's what I have configured, and then the next stage is so this will basically take the VM traffic and it will push it into the firewall. So That's one part. The other part is okay, sorry. The other part is more about the firewall. So if I go inside the firewall, I have done a couple of configuration. So at this stage, what I have is I have this spoke 1 to spoke 2. As I said, you would basically need a bridge over here, and that bridge would basically have the definition of what needs to be done for a traffic which is asked to go to 172.19.0.0.16. So that bridge is built over here. So what it says is, in my case, I've used any protocol. You can use TCP, UDP, whatever you want, but ideally it will be a TCP. In the source, as I said, the 172.18.0.0.16 is my source IP address, a source IP range. So this is the VNet 172.18.0.0.16, and if you look at the destination, 172.19.0.0.16 is our destination. And at this stage, I have just put an asterisk for any port as the destination, but I'll quickly show you going forward about specific port enablement as well. So this is from spoke 1 to spoke 2. Now again, the reverse traffic, as I shared. So in order for the response to go back from the spoke 2 to spoke 1, it has to follow a traffic route, and that traffic route is again defined in the route table. So any traffic coming from 19.0.0.16, which is VM2, our database VM, should go to 172.18.0.0.16, which is our application VM. So that basically completes the full circle. Application talking to the database, and then database replying back to the application. Now just quickly go to the route table 2, which is our spoke 2. And again, over here I have defined, so if any request needs to go to the application VNet or application spoke, then that is basically 172.18.0.0.16, and the next hop should be our firewall. So what we have done in a nutshell is at the spoke 1, application makes a request to the database. Database basically it says, okay, once it is asked for database, let me throw it to the firewall. Firewall takes the request and says, okay, you're asking for 172.19.0.0.16, so that's okay, that's fine, I can connect you to that. And then in order to get that connection working, I have that and basically throws to the spoke 2, because the reason why how firewall is able to throw this request from coming from spoke 1 to spoke 2 is because of this peering capability, which is already there. So yeah, that's what the firewall will do. And then in the reverse traffic, so what will happen is the spoke 2 will say, I need to reply back. The database wants to reply back to the application, so that's where it will say, okay, the application is sitting on 172.18.0.0.16. I will throw the traffic to firewall. Firewall will again activate and look for, okay, do I have a route for that traffic? So yeah, it's basically coming from 172.19.0.0.16, which is our database, and it wants to go to the application 172.18.0.0.16. So yeah, I do have the particular traffic route available, and then what it'll do is it'll throw the traffic to our particular VM, which is our application VM. So in order to just test this entire thing, I'll quickly open the two VMs. So this is our VM1, which is our spoke 1 VM. And if you look at it, what I have done is I have just quickly enabled IS server on this. And if you see, this is the default IS page. I've just quickly added a couple of headers in this. So this is VM1, 192, that's my public IP address, and that 1804 is my private IP address. Now, if you look at the second one, this is my VM2, and I can access the VM2 on my public IP address. So VM2 has a public 1904. As I said, that's in spoke 2, the 172.19.0.0.16. So it's taken IP address of 4. And then, so this is an IS application I've deployed on the VM2. I'll quickly show you that. And then again, there is another instance of that IS application, which is running on port 82. So I have also deployed the same application on port 82. And as you can see, I cannot access, because if you see this 7.19.0.0.4, I cannot access the port 80 or port 82 at this stage. And that's because it's not yet connected. So all good over there. Now, if I come to my VM2, so this is my VM2, I have an IS application, and as I said, I have two different instances of my IS default web application running. One is running on port 80, as you can see over here, this is running on port 80, and this is the default application which is running on port 82. So all good over here, and if I refresh this, then I get the port 80 reply, which is VM2AA. And if I put port 82 over here, then I would get port 82 as the reply. So all pretty well working at the VM2. And if I want to access VM1, as you can see, I can access the VM1 on the public IP address. But if you look at the private, which is 72.18.0.0.4, as it lies in the address range of 172.18.0.0.16, I cannot access internally. It came from the cache. I'll just refresh that. Eventually it will go. So let me even clean the cache over here. So I'll just delete this. Okay, okay. So all right, it's not working at this stage. So what I need to do is, as I've already done the configuration, which is more about setting the things, now the only thing left over here is, so what we have is we have these route tables over here. Both of these are already configured. I have configured everything in my firewall, which is more about the bridging details. Now what I have not done is I have not attached this route table, this particular route table, to my specific subnet over here. So that's what I will be doing next. So I'll come on the subnet in the specific route table, and what I'll say, I'll associate it. So this is my spoke 2 route table. So I'll basically attach it to the spoke 2, and then if I click OK, that's all good. And if I go to spoke 1, again the same thing. I'll just attach it to the spoke 1 subnet, and I'll have the spoke 1 subnet. That's good, and I click OK. So that's it. So now both the route tables are attached to the respective subnets. So what's going to happen now is, since this particular route table is now attached to this subnet, so as soon as my traffic originates for the database, which is the VM2, it will automatically be thrown to the firewall. So now if I go back into my specific VMs, so let me go back into my VM1. So that's my VM1, and that's my VM2. So if I come over here and if I just say refresh, so everything locally is working, my internet is working all good, no problems with that. My public website access, so public IP based access on the VM2, that's all good. And this is my VM1, and internet is working, I'm pretty sure. Yeah, it's working. So yeah, through the public website I can access the public IP, I can access it. To the public IP I can access the port 82 as well. Now if I access using the private IP address of VM2, I'll just refresh that, and as you can see, I can quickly access it. So it's pretty much accessible. So what's happened now is, if I go back to the diagram, so this particular request basically got generated over here, and it went to the firewall, and from the firewall it went to the port 80. So the port 80 IIS application deployed is responding back. Now if I go back to my VM, and now let's try to access this same IIS application running on port 82 using the private IP address. So if I click on that, as you can see, I can access the port 82 version as well. And that's because at this stage, if I go back to my firewall and if I click on this, then it's asterisk. So any port, whether 80, 82, it will allow everything to go through. And so now let's go to our VM2, and let me show you that. So we are on VM2 now, and as you can see, everything is still working after attaching my route table. Now if I refresh this, I can access my VM1. So this is where the entire magic is happening. So the firewall is acting as a bridge. So let me just quickly go back to my Azure portal. So I'll go over here, and what we need to do now is we need to test the port. So what I'll do is I'll just enable port 82 over here, and any traffic which wants to go to port 80 should be blocked, but any traffic which is going to port 82 should be allowed. So eventually this should be pretty quick. It takes some time to update the firewall rules in the firewall, because it gets updated and then it also gets deployed. So if we so that's how it is. The other thing also, you can test if you want, when you are doing your own testing as a setup, you can basically disconnect this particular route, which is the spoke to the spoke 1, And as soon as you disconnect that, what will happen is the traffic will basically will, like if you go from VM1 to VM2, the traffic will go to VM2, but it will not be able to come back, because as I said during the diagram, that in the route table in the bridge we basically define anything coming from spoke 1 and asking to go to spoke 2 should be listed in the route table definition of the firewall, and anything which is coming from spoke 2 and wants to go to spoke 1 should also be defined. So if any one of that route is missing, then you will not be able to complete that entire transaction. And that's really important, that you need to have both from spoke 1 to spoke 2 and spoke 2 to spoke 1 listed in your routing configuration for the specific firewall, so that the bridge basically works in both the directions. So yeah, I think it should update in a tick. Before we even, okay, so in the meanwhile, since it is updating, I'll quickly show you something else. I came across this GitHub repo where you can go and deploy a firewall workbook, and that firewall workbook is really good, because what it gives you is it gives you a pre-built, pre-set up all the graphs and views for your firewall, and you can just enable that, and it basically needs so any workbook can only run on top of log analytics workspace. So if I go back to my environment, so what I've done is I am pushing all the logs from firewall to VNet to subnet to the VMs into this Azure network workspace, which is my log analytics workspace, and then I'm consuming that log analytics workspace with this workbook. So if I open this workbook over here, so what over here I have is I can go and select Azure networking workspace, and then I can select all. So that's Azure firewall, and I think I have only one firewall, so that's fine. This is my hub firewall, that's fine. And as you can see over here, it pretty much quickly cooks everything for me. So it shows me Azure firewall, the different I have different configuration in that. So there is a app, there is a network, there is a DNS, and then there is also a FQDN based traffic management. So all that is well configured. It shows how many events have happened. It shows me a firewall over the time. So this is currently showing 28 days. I can make it last 5 minutes, which should be very skimmed because not much has happened. And even I can make it for 15, then I should say yeah. So it's pretty skimmed because I haven't done much on the firewall side apart from accessing those websites which would have blocked initially when we were trying to access them. But yeah, that is another good thing which you can enable inside your environment, so that you can get a straightforward graphical view of what's happening. I think the configuration for the firewall is already updated. So if I close this and again open that, it should basically show 82. So that's the only port which is allowed. Hopefully if we test now, everything should work fine. So just to get back and show you what exactly has been done. So at this stage, what it's saying is spoke 1 wants to talk to spoke 2, that is 172.18 is the source, 172.19 is the destination. Only allowed traffic would be on port 82. So if I come back over here in my VM1, and if first thing is I should clean the I should clean the cache. So I'll just go and clean the cache. I'll clean it. So once you clean the cache, it cleans for all the instances, but just to be on the safer side, I'll clean it for both the private private IP based requests which we have made to 2 different instances. So if it doesn't work, we will basically open an incognito version and let's see how it works over there. But yeah, if I refresh this, as you can see, I am not allowed to access this particular endpoint because it's denied. I haven't listed port 80 over there, but I have listed port 82. So yeah, it allows the traffic through port 82. So yeah, it gives you a very detailed way of how you can manage your traffic going through the different areas. But yeah, and as you can also see, it's not about one port. You can specify multiple ports, and you can even specify port range. So yeah, it has all those flexibilities available. I would highly recommend everyone to go through this and try it firsthand. It's a great experience. And also what I have done is I'm building a I'm building a repository in GitHub for this, so I'll quickly show you that as well. It's still in progress, so I'll post the link for this repository. But yeah, all the components which you have seen on the screen, which I have deployed in my environment, eventually the plan is that once I'm done, you should be able to come over here and deploy it in your own subscription. But at this stage, you will find only a couple of things in there. So I have just placed the ARM template for the firewall, and then also there is a deployment file how you can deploy the ARM firewall. But yeah, I'll be updating this, and maybe in a couple of days time, you should see all the components which I have deployed in my environment to be available over here. So hope you liked the video, and thanks a lot for watching. Happy coding.